Hello everyone, welcome to our presentation. Today we're diving into Unit 2, Lesson 2. The focus is on landform maps and climate maps. We'll explore Earth's features and weather patterns together. On this first slide, I want to introduce what we'll be covering. We'll look at landforms, climate zones, elevations, and weather. I'm excited to guide you through these fascinating topics. So let's get started and discover the amazing features of our planet. So what exactly are landforms? Well, landforms are the natural features that make up the Earth's surface. These are not man-made. They are created by nature over long periods of time. Think of things like plains, deserts, mountain ranges, and different elevations. That's what we mean by landforms. They play a huge role in shaping how we live and how we interact with our environment. For example, the type of land we find in an area can influence everything from the climate to the vegetation that grows there, and even where people choose to settle. And it's fascinating to realize that all these features are formed through natural processes that have been happening over millions of years. This long history of Earth's shaping really helps us understand the landscape we see today. When we talk about landforms, it's also important to understand some key vocabulary, like what a landform actually is: a natural feature of the Earth's surface and elevation, which refers to how high land is above sea level. These concepts will help us better understand the diversity and complexity of Earth's surface features. When we talk about plains, we're referring to large, flat areas of land that often stretch for miles. These regions are usually treeless or have very sparse vegetation, which makes them quite distinct from other landforms. The key characteristics of plains include their flat or gently rolling terrain, which provides a smooth landscape. Because of their open and unobstructed nature, plains are ideal for agriculture. Farming becomes much easier without steep slopes or dense forests blocking the way. Additionally, plains have historically supported human settlement because the land is accessible and fertile. You might be familiar with some famous examples around the world, such as the Great Plains in the USA, the Pampas in South America, the steppes in Asia, or the African savanna. Now let's test our understanding with a quick question. What is the primary characteristic of plains? Is it steep mountains, large flat areas of land, deep ocean trenches, or volcanic activity? The correct answer is B, large flat areas of land. Remember, this flatness is what sets plains apart and makes them such crucial regions for agriculture and settlement. Let's take a closer look at deserts, which are fascinating landforms. So, what exactly are deserts? They are mainly sandy regions that receive very little or no rainfall at all. Because of this, deserts experience some of the most extreme temperature variations found on Earth. During the day, it can get incredibly hot, while at night, the temperatures can drop sharply, sometimes becoming quite cold. Now, what are the key characteristics that define deserts? First, they have minimal precipitation, meaning rain is rare or hardly ever occurs. Second, they experience extreme temperatures, hot days and cold nights. Third, the vegetation in deserts is sparse because plants struggle to survive with such little water. Finally, deserts cover about 20% of Earth's land surface, making them a significant part of our planet's geography. Some well-known examples include the Sahara in Africa, the Arabian Desert, the Kalahari, and the Gobi in Asia. These serve as great examples of the diversity and scale of deserts around the world. Before we move on, here's a quick practice question. Which best describes a desert? Is it A, a region with abundant rainfall, B, a sandy region with little or no rainfall, C, a flat plain with dense forests, or D, a mountainous region with snow? The correct answer is B, a sandy region with little or no rainfall. Keep that in mind as we continue exploring Earth's landforms. Let's talk about mountain ranges, which are groups or chains of mountains formed by tectonic plate movements and geological processes over millions of years. These landforms are some of the highest on Earth, making them truly impressive features of our planet's surface. Not only are they towering structures, but they also play a crucial role in creating weather patterns. For example, when moist air hits a mountain range, it can cause increased precipitation on one side, affecting local climates. They influence climate and precipitation in significant ways, shaping ecosystems and human settlements alike. Mountain ranges also provide valuable resources such as minerals, water sources, and even tourism opportunities. You'll recognize some of the most famous examples around the world, like the Rocky Mountains in the USA, the Himalayas in Asia, the Andes in South America, and the Alps in Europe. So when we ask, what is a mountain range? The correct answer is a group or chain of mountains. It's not just a single mountain or a flat plateau, but a connected series of peaks and ridges. Understanding these formations helps us appreciate their importance in shaping our environment and influencing our climate. All right, let's talk about elevation, a key landform feature. So, what exactly is elevation? It's simply the height of land above sea level, and we usually measure it in feet or meters. Now, sea level is our reference point, which is at 0 feet. Think of it as the baseline for measuring how high or low land is. Higher elevations tend to be cooler, and that's because as you go up, temperatures drop. For example, mountain peaks often stay snow-covered even when the surrounding regions are warm. This temperature change is approximately 3.5 degrees Fahrenheit for every 1,000 feet of elevation. So, elevation really influences both vegetation and climate. Plants and animals adapt based on how high they are. It also impacts atmospheric pressure. The higher you go, the lower the pressure. All these factors are interconnected and help shape regional climates. To sum up, elevation is a crucial factor in understanding landforms and climate patterns. Now let's test your understanding with a quick question. What does elevation measure? Is it A, the width of a mountain, B, the depth of the ocean, C, the height of land above sea level, or D, the distance between two cities? Remember, it's C, the height of land above sea level. Let's take a closer look at landform maps. These maps are really useful tools because they help us visualize what an area looks like by using colors to represent different landforms and terrain features. It's like giving us a quick, visual summary of the landscape. So why do we use landform maps? Well, they make it much easier to understand the terrain, whether we're planning development projects or studying geography. Instead of just looking at a flat map with numbers or labels, we get a clear picture of the physical features of the land at a glance. Now, to help us interpret these maps easily, there's a color coding system. Green represents plains and grasslands. These are the flatter, more open areas. Yellow indicates deserts and arid regions, which are typically dry and sparse. Brown shows mountains and highlands, highlighting the elevated and rugged terrain. And finally, blue is used for water bodies and oceans, reminding us of where the water is located. By understanding this color system, we can quickly read and interpret landform maps, making them an invaluable part of geographic study and planning. They connect the physical features of the land to the visual cues we see, helping us better understand our environment and make informed decisions. Let's explore the world of climate maps. So, what exactly are climate maps? Well, they are visual tools that give us a general overview of the climate and precipitation patterns in different regions. They use colors to represent various climate zones or levels of precipitation, whether it's rain or snow. This makes it easier to see at a glance how different areas compare in terms of weather conditions. Now, the main purpose of these maps is quite important. They help meteorologists and scientists predict and report weather patterns more accurately. By understanding the climate zones, they can better anticipate weather changes and trends. Additionally, climate maps are essential for planning in agriculture, like deciding what crops to plant, and for disaster preparedness, such as preparing for floods or droughts. Let's also clarify some key terms. When we talk about climate, we mean the long-term weather patterns of a region, what you can expect year after year. Precipitation, on the other hand, refers to any form of water, rain, snow, sleet, or hail that falls from the sky. And a meteorologist is a scientist who specializes in predicting and reporting the weather, often using tools like climate maps to inform their forecasts. In summary, climate maps are valuable for understanding our environment, for scientific research, and for practical planning. They give us a visual sense of how climate varies across regions, which is a vital part of the broader picture of weather and climate understanding. Let's take a moment to explore Earth's climate zones and understand what makes each one unique. Starting with the tropical climates, these are the hot and humid regions located near the equator. You'll find lush tropical rainforests here, characterized by heavy rainfall throughout the year, as well as tropical savannas, which experience seasonal rainfall. Moving on to subtropical climates, these are the warm regions that lie between the tropics and the temperate zones. They include areas with hot summers and dry conditions, like some deserts and humid subtropical zones with high humidity and distinct seasons. Next, we have temperate climates, which are marked by moderate temperatures and 4 distinct seasons: spring, summer, fall, and winter. These zones include humid continental regions, with cold winters and warm summers, as well as oceanic climates that tend to be mild throughout the year. Finally, polar climates are found near the poles and are characterized by extremely cold temperatures. You'll find polar tundra, with frozen ground, and polar ice caps, which are covered permanently with ice and snow. Understanding these climate zones is essential because they influence the environment, the types of ecosystems that develop, and even human activities. Recognizing these differences helps us better appreciate the diversity of our planet. Let's talk about the equator and how it influences the climate around the world. So, what exactly is the equator? It's an imaginary line that runs around the middle of the Earth at 0 degrees latitude. Think of it as the Earth's waistline, dividing the planet into the northern hemisphere and the southern hemisphere. This division is fundamental because it helps us understand how sunlight and climate patterns vary across the globe. Now, the equator is particularly important for a few key reasons. First, it divides the Earth into 2 equal halves, which is a simple but powerful way to understand global geography. Second, because of its position, it receives the most direct sunlight throughout the year. This means the sun's rays hit this line at a near-perpendicular angle, making it the hottest part of the planet. As a result, regions along the equator tend to have hot, tropical climates year-round. Additionally, this intense solar radiation creates some of the hottest climates on Earth. Think of the lush rainforests in Central Africa, South America, and Southeast Asia. These are all near or along the equator. The line itself passes through several continents, including Africa, South America, and Asia, which explains why these regions experience such consistent heat and humidity. So, in the context of our overall discussion about Earth's climate, understanding the equator helps us see why certain areas are hot and humid while others are cooler. It's a crucial factor in understanding global climate patterns and the distribution of ecosystems across the planet. Let's take a closer look at temperature patterns and climate zones. As we move across the globe from the equator toward the poles, you'll notice a clear temperature gradient by latitude. Starting at the equator, which is at 0 degrees latitude, we find the hottest temperatures. This is because the equator receives the most direct and intense solar radiation throughout the year. Moving north or south to the tropics, around 23.5 degrees N and S, the climate remains very warm. These regions are still fairly close to the equator, so they get a lot of consistent sunlight. Further away from the equator, into the mid-latitudes between 23.5 degrees and 66.5 degrees, temperatures become moderate. This zone experiences more variation and less direct sunlight compared to the tropics. Finally, in the polar regions, between 66.5 degrees and 90 degrees, temperatures are the coldest. Here, the sun's rays hit at very oblique angles, spreading their energy over a larger area and passing through more atmosphere. That results in much cooler conditions. So, why does this temperature pattern exist? The main reason is that the equator gets the most direct and intense solar radiation. As you move toward the poles, the sun's rays strike at an increasingly oblique angle, reducing the amount of energy received. This explains why tropical regions are warmer than polar regions. And just to clarify, the correct answer to why tropical regions are warmer than polar regions is because they receive more direct solar radiation. This is a fundamental reason for the variation in climate zones across the globe, tying back to our overall theme of understanding Earth's climate patterns. Now, let's take a look at the different uses and applications of maps. First, landform maps are incredibly useful for a variety of purposes. For example, in urban planning and infrastructure development, they help us plan cities, roads, and buildings by considering the terrain. This ensures that development is efficient and sustainable. Next, there's agricultural assessment. Maps allow us to evaluate land suitability for different crops and farming activities, helping farmers make better decisions. Disaster risk assessment is another vital use. By identifying flood-prone areas, landslides, or earthquake risks, we can prepare and mitigate potential damage. Environmental conservation is also a key application. Maps help protect ecosystems and natural habitats by showing us where they are and how they might be affected by development or climate change. In mining and resource extraction, maps help locate mineral deposits and natural resources, making exploration more efficient and less invasive. Now, moving on to climate maps, they play a crucial role in weather forecasting, allowing us to predict weather patterns and climate trends. This information is vital for many sectors, especially agriculture. Climate maps help us select the most suitable crops for specific climate zones, optimizing yields. Water resource management is another important application. Maps assist in planning water distribution and designing irrigation systems to ensure efficient use of water resources. Urban development also benefits from climate maps, as they guide the design of buildings and infrastructure that can withstand local climate conditions. Finally, in disaster preparedness, maps are essential tools. They help us plan for hurricanes, droughts, and floods, enabling communities to respond effectively and reduce risks. Overall, maps are powerful tools that help us understand our environment better and make smarter decisions across many areas. Let's take a closer look at some practice questions to reinforce what we've learned. First, what are the main characteristics of a desert? The correct answer is B, sandy regions with little or no rainfall. Deserts are defined primarily by their dry conditions and sandy or rocky landscapes, not by heavy rain or dense vegetation. This highlights how climate shapes these unique environments. Next, we have a question about landform features. Which one is not a key landform feature? The answer is D, oceans. While oceans are significant geographical features, they are not classified as landforms. Instead, landforms include features like plains, deserts, and mountain ranges, which are land-based features that shape the Earth's surface. Moving on, let's consider how we interpret landform maps. What color represents plains? The answer is C, green. On most landform maps, green is used to show plains or lowland areas because it indicates lush, flat, and fertile regions. Recognizing these colors helps us quickly understand the geography being presented. Finally, why do meteorologists use climate maps? The correct answer is B, to predict and report weather patterns. Climate maps are essential tools that help meteorologists analyze long-term weather trends and patterns, enabling accurate forecasting and better understanding of regional climates. All these questions tie back to the main theme: understanding Earth's physical features and climate, which is fundamental for comprehending our environment. Now, let's take a look at some practice questions to reinforce what we've learned. Question 5 asks, how does distance from the equator affect climate? The options include no effect at all, closer to the equator meaning a cooler climate, farther from the equator meaning a cooler climate, or that distance doesn't matter. The correct answer is that the farther you are from the equator, the cooler the climate tends to be. This highlights how latitude plays a significant role in determining temperature patterns around the world. Moving on to question 6, what is elevation? The choices involve the width of a mountain, the type of rock formation, the height of land above sea level, or the distance between two peaks. The correct answer is the height of land above sea level. Elevation is crucial because it influences climate. Higher elevations are generally cooler, affecting local weather conditions. Question 7 asks, which climate zone is hottest and most humid? The options are polar, temperate, tropical, or subtropical. The right answer is tropical. Tropical zones are near the equator and are characterized by warm temperatures and high humidity all year round. Recognizing these zones helps us understand regional climate differences globally. Finally, question 8. What do colors on a climate map represent? The choices include political boundaries, different climate or precipitation zones, population density, and transportation networks. The correct answer is that colors on a climate map represent different climate or precipitation zones. This visual tool helps us quickly identify climate patterns across regions, which is essential for understanding geographic and environmental variations. These questions tie into our overall theme of understanding how geographic features and locations influence climate. They emphasize the importance of factors like distance from the equator, elevation, and how we interpret climate maps visually. Thank you for joining me as we wrap up our presentation. Let's go over the key takeaways from what we've learned. First, landforms are natural features of Earth's surface, including plains, deserts, mountains, and other elevations. These features shape the landscape we see around us. Next, landform maps are really useful tools because they use colors to help us visualize different terrain types clearly. Similarly, climate maps show us patterns of precipitation and temperature across various regions, giving us a snapshot of the Earth's climate zones. A crucial point is the role of the equator, which is the warmest region on our planet. As you move farther from it, the climate generally gets cooler. This concept helps explain global climate variations and patterns. Both landform and climate maps are essential tools used by scientists, city planners, meteorologists, and environmentalists. They help us understand our environment better and make informed decisions. Finally, understanding these maps isn't just academic. It has real-world applications. For example, farmers use this information to choose the best crops for their land, city planners develop infrastructure suited to local terrain and climate, meteorologists predict weather more accurately, and environmentalists work to conserve natural habitats. Overall, mastering these tools enhances our ability to comprehend our planet and plan for a sustainable future.